All right, guys. Well, we're back with our next type of transformation, um, and we're going to focus on reflections. So let's jump right into it. So a reflection might have previously been called a flip. It creates a mirror image about the line known as the line of reflection or the line of symmetry. So we've all worked with the line of symmetry and creating a mirror image or a balanced image around that. Um, The pre-image and the image are equal distance from that line of reflection. So there has to be perfect balance, perfect symmetry. Now, psychologically, our brain works very well to see symmetry, especially when there is a vertical line of symmetry or again a line of reflection. These are kind of interchangeable terms for us. So if we can see the line of reflection, it does make things a whole lot easier. Now we're going to focus on a few different ways of reflecting. Um, there's six, and some of them I'm even going to say, we're familiar with this map layout, this map format. So let's just look at these rules real quick. If we want to reflect over the x-axis, look at what that says to do. So reflecting over the x-axis, notice it just says take your original x and y and change the sign of the y. That's all we have to do. So take the y, change the sign. That's your new point. For the y-axis, we're going to change the sign of the x. So again, understand what the rule is telling us to do. Take a value and change its sign. Very simple. For the next two, I'm giving you guys these formulas. And again, I don't believe that these formulas are extremely challenging. If you look at it, it says when we're given the equation y equals some number, all we're going to do is take 2 times that number and subtract the original y. Not the most complicated formula. But I'm going to tell you count. If you can graph the line of reflection, then you can count in any of these. For every example here, you can just count, but you have to be able to graph the line of reflection. So remember, y equals is a horizontal line, x equals is a vertical line, and then just count, and we'll do some examples. To reflect about the line y equals x, it tells us swap the x and the y. And for y equals negative x, it tells us swap them and change their sign. So again, we're just following the rule. Once we know how the rule works, we just have to follow it. So x and y become yx. All we're doing is switching the order. We did that in Algebra 1. We did the inverse of points. And for our last example there, y equals negative x, we're going to switch their order, but also change their signs. Now, this is a really handy thing to have in front of you as you do some examples in practice. I would have these rules in front of me. This video, again, by Mashup Math, excellent video and animates the steps of all these reflections and shows you how you can do all of these just by counting. You don't have to memorize anything special. I'm telling you, keep those rules right there in front of you. I suggest you watch that video. Let's look at a couple examples. And we're not going to do every single one, but we'll do a couple. So we're going to graph the polygon and its image after a reflection. So let's graph the original. So we're going to graph the original. A is at -1, 5. B is at -4, 4. And C is at -3, 1. So there's our starting triangle. We're going to graph over the y-axis. So identify the y-axis. That's our line of reflection. Now, again, imagine taking this graph and just flipping it over that red line, the y-axis. Well, A was 1 to the left, so A prime is 1 to the right. B was 4 to the left, so B prime is 4 to the right. You can do this just by counting. C was 3 left, C prime is 3 right. And there's our new image, triangle A prime, B prime, C prime. Now again, if we follow the rules for the y-axis from our notes, it says negative x comma y. So A prime, we're going to take the x value from A and change its sign, keep the y. For B, negative 4, this says change its sign, multiply by negative 1. So negative 4 becomes 4. Keep the y. C prime, negative 3 becomes 3. Sorry, negative 3 becomes 3. Keep the y. So we can write it out. In fact, we will be asked to write it out. But we can literally do this just by counting. Okay, let's try the second one. Again, we're going to graph the original. A is at 0, 2. B is at 4, 5. And C is at 5, 2. We're going to reflect over the x-axis. Well, again, from our notes earlier, from our rule, reflecting over the x-axis, our rule says take our x and y, keep the x, change the y sign, multiply by negative 1. So for A, which is at 0, 2, we're going to keep the 0 and change the sign. B was at 4, 5. We're going to keep the 4, change the sign. C, which is at 5, 2. We're going to keep the 5 and change the sign of the y. And that's how we get our A prime, B prime, C prime. So we have 0, negative 2 for A prime, 4, negative 5 for B prime, and 5, negative 2 for C prime. Notice B was way above the axis, so B prime is way below the axis. It was 5 up, now it's 5 down. Doing the exact same thing. We're going to graph the original. So let's graph our original. A is at 2, negative 1. B is at -4, -2, and C is at -1, -3. Here's our line of reflection, y equals 1. And again, we have a formula that can be used. Y equals a number, so the rule says keep x by itself, 2 times the number from the equation minus the original y. But my suggestion to you is count. A is 2 down, A prime is 2 up. C is 1, 2, 3, 4 down. So now we're going to go 4 up. 1, 2, 3, 4. B out here is 3 below the red line, so we're going to go 3 above the red line. Connect the dots. And you have your reflection. You have to be able to graph the line y equals 1 so that you can count. Same thing in the next example. You have to be able to count, you have to be able to graph the line x equals -3 as your line of reflection so you can count. If you can't count, then if you can't graph that line, then you have to use the formula from the rule. Let's do another one. We have our original. So I'm going to just give myself a little room over here. I'm going to write down all these ordered pairs. So A is at -3, 2. B is at -1, 2. C is at -1, 4. And D is at -3, 4. Those are my original points. My line of symmetry is y equals x. Now what I'm going to do is I'm going to go to my notes, and y equals x, the rule says, well, sorry about that. The rule says take your x and y and swap it for yx. So A prime, I'm going to take the x and the y and I'm just going to switch them. It becomes 2, -3. B prime becomes 2, -1. C prime, 4, -1. And D prime, 4, -3. Now, in that video, the mashup video, they showed you how to do it by counting. But the end result is follow the rule. The rule for y equals x says take your x and y and just switch them, make it yx. So that's what we did. Now let's plot our points. 2, -3. So 2, -3. And that's our A prime. 2, -1 for B prime. C prime is at 4, -1. And I'm sorry, d prime is at 4, -3. We can connect the dots. And we have our quadrilateral. And if you turn the paper, the monitor, tilt your head, if that red line is vertical, it's a lot easier for your brain to process that we do have symmetry. Okay. And that's all we're doing here. We're going to grab the formula and just do what it says, follow the rule. Here we're asked to graph the triangle and its image after each step of the composition. So let's do number 1. Let's do the first one here. Sorry. We need the original. Right there. So again, I'm just going to copy those points. J is at 3, 1. K is at 4, 2. And L is at 1, 3. And I'm going to plot them. 3, 1. 4, 2. And 1, 3. Okay. Now we're going to do step 1. We're going to translate it. So for every x and y, we're going to subtract 6, subtract 1. So think about that. I'm writing it in vector mode just because it's a little bit shorter to save a little space. So J prime, 3 minus 6 is -3. 1 minus 1 is 0. K prime, 4 minus 6 is -2. 2 minus 1 is 1. And L prime, 1 minus 6 is -5. 3 minus 1 is 2. So if we look at this, sorry, what did this translation do? It went left and down. J prime is -3, 0. -3, 0. Well, did J go left and down? Yeah. So it looks like we're on track. K is at -2, 1. K prime. And L prime is at -5, 2. So there's our new triangle. Now they should look congruent. It's just that it was slid left and down. Step 2. Is we're going to reflect over the line y equals -x. So I might want to see that line, y equals -x. And again, we have to be able to graph that. Y equals -x. But ultimately, what I want to do is grab the rule for that translation, which says xy becomes -y, -x. So J double prime I'm going to take the -3, put it to the back, and change its sign. I'm going to take the 0, bring it to the front, change its sign. For k double prime, the -2 goes to the back and becomes positive. The 1 comes up front and becomes negative. L double prime. Remember, a composition is step by step, so we never go back to the original. L prime becomes L double prime. The -5 goes to the back but turns positive. The 2 comes up front and turns negative. So again, L becomes L prime, and that becomes L double prime. And now we can go ahead and graph this. We have 0, 3 for J double prime, -1, 2 for K double prime. So that's, and L double prime is at -2, 5. And again, we can see, we can catch any mistakes because it's easy to see. -2, 5. So labeling our points, L, L prime, L double prime. Original after the first step, after the second step. Writing it out. The rule is telling us, change the sign or change the order of the X and the Y. That's as challenging as the rules are. We just have to write them out and be careful. It's not something we can keep track of and just do all in our head. So here we have our composition. Okay, let's stop there with reflections and do a little practice.